Okay, I'm now recording. The date is November 3rd, 2017. This is the normal class meeting of ITSE 2309. Should be getting some more people coming in. We are on module 11, which is functions. This will be our last module before test 2. We will do a test 2 after this. It will not be excuse me. I will not do it next Friday. I will announce, watch your announcements, please, carefully. I will announce when the test will be next Friday. The test will be done online, so you don't have to come in to the campus to take it. So make it available, and I will announce when that will happen next Friday. So I'm going to have a lecture next Friday, and then either the test will become available immediately after that, or we will work from there. Let's see, we have skipped over module 9 in that we have already done that. So now we are, and then last time we did module 10, the data types. Most of the things that we covered there in module 10 were the cast and the convert functions, casting from one data type to another. So today we're going to cover functions and chapter module 10 and 11 go together well. Under the student resources, you will find the PowerPoint slides that I'm going to be using today, if somewhat. I'm not a big fan of the canned PowerPoints. Next, whoop, accidentally just lost my. Where am I? Oh, practice test 2, okay. Well, get back to it here. Okay. Module 11 intro. Module 11 gives you some pages for reading. So the functions that are designed to manipulate strings are on pages 262 through 268. For the numeric data, 268, 272, and 283. So there's about 20 pages there of 20 or 21 pages that are pretty decent reading material and right on target. There are some things that I don't intend to cover, but are good to be covered, okay? And we'll talk about them as we come to them we'll see them in the PowerPoint, but I don't have them in the exercises. And so what is a function? Well, a function is something like y equals f of x, where for some input to the function, it gives us back a known value. So we've seen them in algebra, and in all of our math classes, we see the idea of a function. In computer science, a function typically can return something more than just a number to us. And we're going to see that we have functions that act on strings. They don't typically change the string. For example, if I have a field that has a string in it, I can put two strings together and come up with a new string, but I don't change that particular field. So functions do not change what is passed to them as an argument. That's one of the important points about a function. If it changes it, it's called a procedure. And we don't have very many of those. You want one of those, you pretty much have to write your own. We're going to see in SQL Server that we'll see that you can write your own functions. And some people ask, these are called user-defined functions. And it is possible to write one of your own. Right now, we are only going to consider those which are included in SQL Server. Other functions are covered in this chapter. Most of these are unique to SQL Server, and there'll be some that I'm going to talk about at the end as we have time. So I want to talk about those functions that are included in all SQL. And SQL provides a number of string functions. So because we do that so often, we have them. There's a good tutorial here. It's a bit old. It goes back to Server 2008, but nonetheless, they haven't changed a lot. There's some problems that have occur when working with strings. Lots of times, I believe I told you when I have something, a number that is used as an identifier, and I'm never going to add, subtract, or multiply or divide that number, I will many times store it as a string if I'm never going to add, subtract, multiply, or divide it. And I suggested that it might be easier to store it as a string. There's no hard and fast rule on this that says you have to always store it as a string, but sometimes I will. There is some issues with that. Numeric data sometimes does not sort exactly right. For example, the number 77 stored as a string would sort greater than the number 695, 695, if I'm treating them as numbers, okay? There are issues when a first name and a last name are stored in a string. I gave you basically 3 rules of database. I called them the first normal form. We're going to talk more about that just towards the end of this class, normalizing our data. And our first normal form said that let's see, there was no order. Okay, first of all, it says no duplicate rows. Every row has to be different in some field. This brings up the idea of the primary key. Is there one field I can get that this field has to be unique? We'd like to have it be 1, but sometimes we can't. So no duplicate rows. Second, data are accessed by content only. So I'm never going to ask for the 3rd row. And this kind of belies the idea of top function. Give me the top one of the query. But then the query can be sorted. The database isn't. So I'm never going to say, give me the 3rd row of the table, even though I can in database. And the last one is a field contains only one value. So if you have a first and a last name stored in the same field, and you are ever going to use that as the first name, last name, you have violated that 3rd rule of the first normal form, meaning that you have 2 values stored in the same field. Now, if you're always going to use the name, if you just have a name, it's first name, last name, and it's just an identifier, then you can do that. But when you start breaking them out, you're saying, wait a minute, I have 2 values there that I'm interested in. Another one would be phone numbers where you talk about the area code. Is that a unique value? And there comes a point where you have to decide whether to break these out into 2 separate fields or not. If you're doing this a lot, you need to think about that rule that says only 1 value per field. So I really need first name and last name as 2 separate fields. Let's see where we're going here. It's been a while since I wrote these slides. Okay, there are 2 basic string functions. Our textbook does not mention that, but all functions in general fall into 2 broad categories. There are functions that return information. They give me something about that string. How long is that string? What is the position of some character or substring within that string? Good morning. And then there are what we call, so those are called observer functions. The length of your last name. My name is Smith, so the length of my last name would be 5 characters. would return 5. Functions that return a new or different string. So those are called constructor functions. And we have in computer science, we talk about the difference between constructors and observers. For example, we have seen the idea of constructors and observers in our SQL. Create table is very clearly a constructor function. Insert into, delete from, updating tables are constructor functions. They change the data. A simple select function, which we have been using for the most part, is an observer function. It doesn't change the data in the table. So in computer science, we talk about that a lot. Next. Okay, and I've broken these out into string observer functions. The length, len, roll that up a little bit, returns an integer representing the number of characters in the string. In SQL Server, only in SQL Server, it counts leading spaces, however, it does not count trailing spaces. So if a string contained only spaces, it would have a 0 length. Okay. Now, we have seen this. If I have a field, like a last name, for example, that is required, can I check that it's not null? I probably also want to check that its length is greater than 0. Otherwise, I could have a string in that field that contained only spaces. Or someone could insert the string quote, quote. Now, many times this is not considered a null string, so this is a 0 length. It would also include strings that contain only spaces. I don't want a last name that contains only spaces because that would really be confusing. It would look like that person didn't have a last name, but they do. It's spaces. Next one is char index, returns an integer representing the position of the first occurrence of the find string. So I want to find, give me the index of something. For example, char index of in the string my name would return 4 because it is at position 4 in the example down at the bottom. Here, let me point with the mouse. Okay. Unlike C in SQL, when we're talking about strings and arrays, and there are arrays in SQL, they start at position 1, not position 0 like they do in the C programming language. If you don't give it a position, I can say start at find the string M. So if I was searching for, so if I said char index of M in my name, and I gave it the position 3 to start, it would find the one at position 1, 2, 3, 4, 5, 6. It would return position 6 because the first M it found after 3, on or after 3, would have been at position 6. Questions? I'm not going to cover this one as much. Pattern index. It's like char index. However, it allows wildcard characters in the find string. And we've talked about those. Those are the question mark and the asterisk. Let's see. There's something I wanted to say here, and I just lost it. And let's see, I talked about these constraints. Many times you will want to constrain it, not null, and also that it has at least one printable character in it. For example, I would constrain the middle name, or so the middle initial or the middle name. I might allow it to be null. It's okay not to have a middle name or a middle initial, But if you have one, then its length has to be greater than 0. So if I write the constraint on the constraint lname 0 length would not stop it from being null. I have to have two constraints, one to stop it from being null and the other to make the length greater than 0, because null, greater than, less than, anything length does not apply to null. Questions? Another example I give you here is this must be my family database. Smith family database. Only last names that contain Smith are allowed. Thus, Smith, Smith and Wesson, Smithwick, Smithers are all valid, but Smitty is not because it doesn't have SMITH in it. So here would be the constraint. Check that the char index of Smith in lname is greater than 0. If it does not find it, it returns 0. 0 means it's not there. If this were the C programming language, we couldn't get away with that. We'd have to return something like -1, I suppose. Are they always? No. The question was, are these always used in the constraints? No, they are not only used in constraints, and a constraint doesn't have to have the string functions in it. So they have many other uses. One of the first database jobs I ever got when I was a budding young programmer for Austin Independent School District was that they had their database set up with their students' names in it, last name, comma, space, first name. And that didn't last very long because it gave them a lot of trouble when they wanted to try printing out the diplomas. You don't want your diploma with your last name, comma, space, first name. You want first name, last name, at least as in English. I had to break that out and put them in separate fields. And that's a very common task to do. And I would use it using the string functions. So I would create another table, and using the string functions, I would create. We're going to find, I can create a table from a query. A query will create a table. Here's an interesting point, this last little sentence here. I have forgotten how to set the case sensitivity on the server. I meant to look that up before class. Whether or not the search on the constraint, on the char index is case sensitive or not depends on the server settings. By default, if you just installed a server, all of the searches and the where clause and everything for strings are not case sensitive. It will ignore uppercase, lowercase, even in the data strings. Okay. Now I can change that, and I usually do. I have just slipped my mind how to do it. There's a setting on the server that I can change for that, and Google would be my friend. I was planning on looking that up. Next, string constructor functions. These guys are going to return a new string to me. Okay. For example, ltrim trims off any spaces on the left side of the string. Ltrim s returns to me a new string. Important point. It is a new string. The result of ltrim is a new string. And it returns a string with either leading ltrim or trailing rtrim spaces. Some databases, Oracle, for example, has another one named trim that takes them off of both ends. I don't really need that one. I can just say ltrim, open parentheses, rtrim, open parentheses, the string, close, close. And that does the same thing. Questions. The important point, it does not change the string passed to it as an argument. It does not change S. It gives you a new string back. So if you're going to put that into a table, you have to insert into a table rtrim and ltrim. Left and right, we've worked with that. Some of you used it. Substring returns a specified number of characters from the string S beginning at position T. So if I know the starting position, I know T, I can say go to T. So in the string S, so the string S is my last name, Smith, starting at position 2, give me 3 characters. M-I-T is what I would get. Questions? Replace. Now, this is still important. S is always the string that I'm looking for. Replace the string with all occurrences of the find string replaced by R. The important point here in replace, it does not change S. It does not change the string that is under search. And finally, concat. Do you know as the word concatenate in our vocabulary? Put them together. So concat phi, phi, fo, and fum returns the string phi, phi, fo, fum. Upper and lower are pretty straightforward. Lower gives me one with all lowercase. Upper returns the same string with all uppercase. And there's some examples. I'm going to move on. Okay. See, I think I have an example of this over here. I'm going to move over. I'll put these I have a table here. I'm naming the table char sort, and I'm going to create the table, and I'm going to insert some values into it. Execute, and I see at the bottom that it executed successfully, so I've already tested it. And what does it have? It has the strings in it, 1, 7. It has 1, 2, 7, and 2, and 3, 9, and 3. So these are integers stored as strings. Okay. If I try to order by, what's going to happen? Hard to get that. I wish there was some way to put that up. Notice that one sorts before of going in ascending order 17, but 17 2 comes after 17. So 1, 17, 2, 27, 3, 39. So this sorts them as if it were sorting an alphabet. So it would be like I had A, B, and then B, and then. Okay. So it sorts by the first digit first because it's a character. Okay. Anything new here? Anything really exciting? Okay. And this is real common. Now, how can we stop this from happening? If I'm going to store a numeric data, digits, as char, which there's nothing wrong with that. It's perfectly okay to store numeric data as character data, particularly if you're not going to be using it in a lot of calculations. In that case, I would require that the length of that field always be 2 or whatever it is. If I've got a 9-digit social security number, I believe that's 9, then I'm going to require that you have all 9 there and that it be only numbers, only digits in there. Okay. So you have to store it. If you have leading zeros, you have to put zeros there. So this one would be stored as 0, 1, 0, 1702270337. Now it would sort correctly. Okay. If I'm stuck with something like this, I can cast them as integers. Order by casts C as int. Okay, now it's going to sort correctly. But the problem that I have here, notice now I'm 1, 2, 3, 17, 27, 39, whatever it is. Yeah, I could have two different values. For example, 0, 1, and 1 would be different strings, but they would cast to the same integer if that's a problem. One other little issue with casting. Suppose it's got something in there that isn't an integer. Oh, your input people will be famous for typing in O instead of a 0. The hardest problem that I ever, not ever, but I remember it well from my beginning days as a young kid trying to debug a BASIC program that somebody else had written. And that person had in BASIC, you do a lot of go to line 15, go to 27. Well, this person had go to line 10, but instead of 10, they had typed 1 O using the capital O instead of 1 0. And it went to line 1. And I was just, I finally traced it down. It had to be here, and I couldn't tell what was going on with it. And I finally looked very carefully at it, and I saw it was an O instead of a 1. It drove me nuts. But what if somebody did that here, and instead of 10, 1 0, they entered 1 capital O? You might not see that, okay? So if we insert something in there, and I can, there's nothing that's stopping me. So if I insert that 1 row, and now when I try to run this, casting it as an integer, we die. Our select statement bars. What should I do? Thank you. Somebody was listening last time when we talked about try convert. Remember, try convert. Now, try convert is not a standard SQL statement yet, but I expect it, I don't know whether it is or not. I expect it to be shortly. We're going to order try convert. Now, remember, try convert, the only thing I'd make a note of, try convert is backwards from cast. So we say cast C as int. Try convert in the parentheses has try convert to int C. So its parameters are backwards and there's no as in it. Slightly different parameter. Now, when I run this and I use the try convert, notice that I still see foo. Why did I see foo at the beginning? No, the letter actually comes after a number because the ASCII code of digits is 48 through 58 in base 10, and the uppercase letters start at 68 and lowercase letters are before that. So in theory, if I were doing them in order, I would have that foo should have come at the end. Why will it always come at the beginning? The answer is, what does try convert return if it cannot do it? Null. Null always comes first because I just have to put it in a consistent place. If you're sorting ascending, nulls come first. If you're sorting descending, nulls come first. That's just the way it's going to work. Nulls are not less than, nulls are not greater than, nulls, it just does the nulls first, and then it sorts the rest of them. Okay? That's just how it's going to work. If I had multiple values that did not convert, there would be no order to them in particular, because one null is the same as any other null. I can find these guys. Let's go in and find them. Find all of them that do not go to an, I can't convert to an integer. And this one gives me all of them that can't. So this one, where try convert int c is null, would give me the ones where I had 2O in there instead of 2. Order by. Right. I could have said select try convert also. Had I said select try convert from char sort. Now this time I'm going to see a null in there. Excuse me. The null did not appear first because I didn't say order by anything. So it just gave them to me in whatever order they were. That's just the order that I put them in the table. Okay. I'm not even guaranteed to get that. But now I see the null value in there. Questions? Let's go back. I give you some suggestions on that. If an identifier, I told you, if it will not be used in mathematics, it makes no sense to add 2 social security numbers. It will always, then it may contain only digits. It may be stored as an integer or as a character string. It's just you make your choice. If the values are relatively small, go ahead and use integer or a number. In general, we're moving away from having integers that are less or fewer than 4 bytes. It is just too much trouble to store an integer as 2 bytes. Anytime I access memory anymore in modern computers, I get 8 bytes. There's no way to access memory and get fewer than 4 bytes back. So we just don't. All integers, even if you say it is a small integer and you're claiming it's only 2 bytes, it's really 4 bytes. So you're not really gaining anything in modern computers by trying to get smaller than 4 bytes, because that's such a tiny little amount. So an integer doesn't cost me much. 4 bytes, well, I remember when 4 bytes was a lot of memory, but anymore, memory is almost free until you try to buy it. So I'm saying if it's 9 digits or so, use integers. There's no hard and fast rule. Here's one. When you use characters, always pad left side with zeros and enforce it with the table constraints. So here are two table constraints that will check that, for example, for your ID, if it's like a social security number or something. Constraint, contact ID length, check that the length is equal to 9, not greater than, not less than. I want to have exactly 9 characters in there. Constraint, valid contact ID, check contact ID like 0 through 9. And any number of those. That must have exactly 9 characters. They have to be. What else do I probably need to check here? This would not enforce not null. So contact ID could still be null, and it would not trigger those constraints. So if I'm enforcing a length and I care about null, I would probably say if I ask for someone's middle initial, I would probably say check that the length of the middle initial is 1, but not enforce null because people don't have it. Sometimes they will enter NMI for no middle initial. So I suppose, should I allow that? I don't know. It's a judgment call. I'm talking about, I'm going to leave this one about the first name, last name. Take a look at this. Select I have here, this is the problem of the name being stored as first name, last name with a comma, a space, and then first name. Okay, we have to have a way to tell where one value ends and the next value begins. Do all names have a comma? Do all names have a comma and a space in them? So I need to check that. So I'm going to look for any data that do not conform to that idea of, is there a comma and a space in all of them? So find a contact name where I don't have, this is something. Let me use the mouse pointer instead of pointing up here with my finger. Anything followed by a comma and a space. There's a comma and a space in the middle there. So something, anything, even nothing, followed by a comma, followed by a space, followed by anything else. So this is just checking, do they all have that comma and space? So to recover the last name, where is the comma and the space? I can get that position with the observer. Char index, comma, space. Second parameter is the name question. So that will tell me the position of the comma. Where is the comma? So if it were my name, Smith, Stephen, select, char index, of, quote, comma, space, close quote. What will this return? 1, 2, 3, 4, 5, 6. This should give me a 6. And notice it does give me a 6. Therefore, the last name is so substring. So the string I'm searching is Smith, comma, space Stephen. Start at position 1 to the character index of the comma and the space -1. Why -1? I don't want the comma. Okay. So this is a very common. This should return the string Smith. What? Line 102. Oh, line 78. What? Oh, I'm sorry. I don't have the select. Thank you. And it does return SMITH. Questions? And I'm going to leave the last one for you to go over. You try it, write a statement that recovers just the area code. And we've using the string. And then I tell you how to do that. Where's my time? Goodness. Okay. I'm going to pause just a minute and I'm going to talk about something else. And we're talking about where we're going with the next class, actually, given that we ever have a next class. One of the things that you're probably noticing about SQL is that we don't have any variables in SQL. Well, we do, but they're all in a table. So the only variable I have to create a table if I want to have a variable and insert stuff into the table. So I know I can save a variable, I suppose, by creating a table, giving it some field name, and putting my data in there. And that works fairly well. But it's still a real pain in the neck. What if I want a variable? Kind of like you are used to in most of your programming languages. And do we have that? Well, not in SQL. We don't have a variable in SQL. But every SQL platform that's worth its beans, including Access even, provides a programming language with it that is wrapped around SQL. So within this and in SQL Server, this is called TSQL, or we call it T-SQL, I guess, T for transaction. So transact SQL, T-SQL, and that is this programming language that's wrapped around this thing. Now, within this programming language, I can declare variables. I can set variables to anything that I want them to be. I can do if, then, else on these variables. This programming language that we have here executes one line after the other. So it is a language that is like C or Java or BASIC or something like that. And it just executes in order, and I can declare variables. For example, here is an anonymous block starting on line 42, ending on line 46, that is this TSQL programming language. I declare a variable, and in SQL Server's language, T-SQL, the variables that you declare begin with that @ sign. So that's how I tell it I'm declaring a variable. I can't just say declare D as sysdate. I have to say at D to cue the system that, hey, you're getting a new variable. This variable comes into existence between the begin and end of that block. It exists, and then I can say set D to system date and time. In other words, get the date right now. And I can say print D. If I just say print D, it won't work. I have to have it begin inside of a begin end block. And really, this is the next class. So we start off talking about a block of code, and then I can have if logic in here. I can reach into the database, and I can do SQL within this. So inside of that begin end block, I'm not limited just to what do I have in C, for example. I can create variables. I can do if then else logic. I can do a while loop or a for loop. And yes, I have all of that here, all of the stuff you're expecting. And I have all of my SQL. So I can just reach into the database and pull some data out, put it into variables, process it further, print it, do other stuff. And so printing is different from selecting from the database. So with print, I can add a lot of extra stuff. Now I'm starting to get something that's a little bit closer to nice looking output. So if I select it one at a time and use print, now I have a lot more formatting ability than I do with SQL. SQL is just the engine that delivers the data. What else was I going to say? Oh, yes, I can give this block, this begin end block, I can give it a name, and I can store it in the server as my own program. So it would live in the server, and I can call it again later. And now I'm well on the road to actually doing some database programming. This class is about SQL. Okay. What I'm talking about here is, but this one would execute. Execute him. And there it printed the time. So it says that it is November 3rd, 2017 at 10:46, and I see it is. Okay. I just thought I would mention that since we are talking about functions, I am not limited to these functions that are provided to us by SQL Server. I can use these to build other larger functions. So I could define a procedure or a function of my own that just returned the last name. And I could use those, the position, the comma position, and I could define a variable called comma position and put the value in there. And then my function that I create would return the last name for everybody, for one person. I give it an argument of a string that has a comma and a space in it. It would check to make sure it has a comma and a space, and then it would give me back the last name. Let me look at the slides quickly. The slides are good to look at. How to use functions, objectives. They just give you all of the string functions. We don't talk about them being observers. Some examples. I think you'd do better looking at the textbook. Sorting a string. Okay, I think I'm ready to talk about numeric functions. Okay, we're leaving string functions. The textbook covers the floor and the ceiling. So there are three that are almost always provided. By the way, I have an error in this slide, and the error is right here. SQL Server gives us a fix function. SQL Server does not. Oracle does. Okay, talk about rounding. What does it mean to round a decimal to some particular decimal place? Oh, you guys know that. You're just being quiet. Means move to the nearest, either integer or, so if I say round 1.5, that's going to round to 2. Round 1.499 rounds to 1. I can also round to any number of decimal places, and you did that in what, junior high? Something like that. I used to teach junior high, and I remember doing that one. So I can round. Typically, I can round to an integer. The text has two that they give you, floor and ceiling. And the floor is says take a fractional value to the next integer to the either to the left on the number line for floor, left on the number line, ceiling, right on the number line. Watch out for ceiling being abbreviated to CEIL. If they all have a ceiling, but many of them, instead of writing it out ceiling, CEILING, they will abbreviate it to CEIL. You'll see that frequently. So ceiling always goes in the positive direction. Floor always goes in the negative direction. And fix. If your system provides a fix, then it's like floor or ceiling, but it goes away from 0. So if I fix 3.1, that would go to 4. If I fix negative 3.1, it would go to negative 4. Okay, so fix, if it has it, goes away from 0. Truncate, on the other hand, chops off the decimal. So rounding towards 0. Questions? One more useful numeric function is the natural logarithm. Oh no, this is math. What is a logarithm? Well, you may have written this as ln of x in your algebra class. Natural log. Now, a natural log says we have this. I don't know how deeply to get into this. Matthew, you know about natural logs? Yep, he says. Okay, we have this constant called Euler's constant. That is this base, natural log base, e. And basically, the natural log of 10 says e to what power is 10. It's a number kind of like pi. And it's not very useful in and of it. Well, it is quite useful in and of itself. But we most of the time in the real world, we use either a log base 10 or a log base 2. But I can switch back and forth if I have the natural log. So I might want, here we go. If I say the log of 32, I'm saying e to what power gives me 32. And I'll find out if I execute that it is 3.465, yada, yada, yada. And that's not real handy to me. That's the natural log of 32. But if I take the log base 2, so 2 to what power is 32? 2 to the 5th power. 2, 4, 8, 16, 32, fifth power. Now, if I take the log, the natural log of 32, and divide by the log of 2, this converts it to a log base 2, and that gives me 5. The natural log of 100 is, I don't know, it's something. I very seldom ever use that, so it's 4.605 something. I very seldom ever use those numbers, but I'm probably more interested in what is the log base 10 of 100. So 10 to what power gives me 100? Well, that should be a 2. And so this is how you convert. When I do that, I get the 2. So this is converting to a base 2, converting to log base 10. Real world applications, I'm usually in either base 2 or base 10 because that's just more commonly done. Now, as you get into any kind of any kind of financial functions or anything where you're calculating interest that is compounded continuously or stuff like that, you're going to have these natural logs floating around in it. So it's one of those functions that's a little strange. Anytime I have a natural log, I'm going to get a non-terminating decimal. I'm going to get an irrational number because E is irrational. So anytime I take a natural log, I'm going to get that irrational number. But most of the time, I'm going to combine it with either floor or ceiling because I'm not interested in, if I'm calculating how many rabbits I have at time t, starting with one pair of rabbits, and then they reproduce at a high rate. At time t, how many rabbits will I have? I'm going to have some power of E in there. Well, I can't have half a rabbit. So I'm more interested in how many whole rabbits do I have. Half a rabbit doesn't do me any good at all. Oh, well. Talk about that. Next. Didn't have a whole lot to say about, let me see what the slides say. Rounding a number. I have one here, is numeric. Let's see if I can get this to. Is numeric. This is a true false. I'm not sure what is numeric an expression means. I think it's any expression. So I think I can ask is numeric and pass it a string, and it will tell me if it's numeric. I would have to do a little bit of work with that. Most of the time, there is a way to look at something and tell me is this capable of being converted to an integer or a number. So this is kind of part of what is SQL provides in the place of try convert. So try convert is not really in SQL yet. I think it will be very quickly. ABS, absolute value, the ceiling and the floor, excuse me, the square root, and finally random. A random number typically gives me a number between 0 and 1. Okay, so it typically gives me a decimal number. Most of the time it does not include 0. Most of the time it does not include 1. So it gives me a decimal number, not 0 and not 1, between 0 and 1. Now, if you want it to be bigger than that, you just multiply it by something to get as many decimals as you want. So The other point is, if I just do rand over and over again, I get the same sequence of random numbers. So it takes an integer, what we call a seed. All random number generators take a seed. And you're Donna's saying, yeah, you know about these? In C++, yes. When you take a random number, you do what we call seed the random number generator. Here we don't have a random number generator, we just have the rand function. And we give it an integer. Okay. So if I give it an integer and generate a random number, I will get I believe I will get a series. If I say rand2, I think I will get a number that is a decimal. I think if I say rand2 again, I will get a different decimal and a different one the next time. As long as I'm in that session. Once I leave that session, if I start over, I'm going to get the same sequence of random numbers. So if I give it a different seed, I will get a different sequence. And this is used a lot in encryption. Most of them don't give you a square root. Most of them give you a way to raise a number to a power. Okay. There's some examples on the next slide. Okay, I see that it is 11 o'clock. I'm not going to go a whole lot longer on this one. I want to get through these guys and get to the, let me see what I've got coming up on the slides. Okay, I'm just about done with what I'm going to do. Then I'm going to talk a little bit about some rather strange functions. I would like to talk a little bit about writing a function. I don't know whether to do user-defined functions in this class or not. I think I probably won't, because those are actually the first topic in the next class. We can do them if anybody wants to do user-defined functions. I have some material that I can give you for it, and it'd be okay if you wanted to go there. Right now, I think I'm going to stick with just these and get to the assignment. So I'm going to pause the record for right now, and let's take a short break. I'm going to stop the share. Resume. Should be recording now. Okay. Found out some information on the next class that will be offered in database next semester is ITSE 2370. Now, that class is it's kind of a big data class, meaning that it's what they call descriptive analytics. It will be offered on Friday, so it's like this one in this time frame, the same as this one, except it will be at Spring Creek. Well, it's works well. It's farther from me, but I can take the train. So I hooked the train around to Parker Road. Yes, ma'am. The number is ITSE 2370, and it does not show at this time that I'm teaching it, but I've been told by the chair that I'm teaching it. So I'm going to be preparing that. I've got the book. I will probably Zoom the class. This is Zoom. Zoom is the recording. And so it'd be available. It will not be an online class, but I think I'm going to be looking at it as that. So I won't have the full the full Canvas suite done up for it. But no, I don't have the syllabus yet. I have just been assigned that class. What are the prerequisites? ITSW is that 1307, 1304. One under mathematics. It is probably an algebra class. Probably just are you up to speed? If you will send an email to Dr. Cervantes, I'm going to put her email up here. If you're in this class, everything's probably okay. I would not be a big one about enforcing the Excel. What is what called? The class is called Descriptive Analytics. And I'm walking around in circles here looking for a marker. ITSE 2370. And I've got a marker. Okay. Dr. Cervantes' email, and I will type this into the screen get it on the recording, is ACERVANTEZ at Collin.edu. The class is ITSE 2370. Descriptive Analytics. It will be at Spring Creek. And she told me the room number, but I didn't remember to write it down. And it will be at 10 o'clock to 1:50 on Fridays. I-123. Okay. Yeah, like I say, the the question, copy me. So just send it to both Dr. Cervantes and me, or me CC, whatever you want to do with it. Just you can put them both just in the two, and I'll chime in. And we're not going to keep you out of that class because you don't have a spreadsheet class. Come on. Well, yeah, if you survive in college, you can figure out how to use a spreadsheet. You can self-teach yourself a spreadsheet. Donna, have you ever used a spreadsheet? Okay, then I'm gonna. Yeah, I would have no problem with any of you being in that class. I haven't gone through it and figured out exactly how I'm going to approach it yet. This is my first time teaching that rubric. So I don't, I've been teaching this particular class for a long time, but that one's a new one for me. So I'm going to have some studying to do. I've got to go read the textbook and work out exactly how I'm going to approach that curricula. Okay, let me finish this up. Okay, we got real numbers here in a table, and see, I have done this table. Okay, I have a table here, create table, and just like it is in the PowerPoint, I named the table real sample, and I put these same data into it. So here they are, insert into real sample, and notice that I have float. Now, remember the data type float. What is the difference between the data type float, also known as real? Float is, the term real is depreciated. Real and float are exactly the same thing. Well, if you took, if you say real in computer science, you mean a number where you have no idea where the decimal point is. Now, we talked last time about if you have a something that is stored as data type numeric. And so if I say it is a number and I give you two numbers after it, number 9, 5, that says I have 9 digits total, 5 of which are always to the right of the decimal place. Now, I have fixed that decimal. Once I have a fixed decimal place, it turns into an integer. Once I tell you that it always has, that money always has 2 decimal places, if we're in dollars anyway, always has 2 decimal places, which isn't true. It actually has 4 decimal places. And did you know that there is a coin? There exists a coin that it takes 100 of these to make a penny. It exists. It's not in circulation. You can't, you'll never get it in your change, but there is. And so because we divide money up into 1/10,000th of a dollar, so money always has 4 decimal places. And in databases, this is true across databases. If you say it is currency, you're saying it has 4 decimal places. Right? Once you fix that 4 decimal places, I've got an integer. You don't have any rounding errors because there's no such thing as a rounding error in an integer. I agree with you, but there is no that we call that the granularity of the integer. I don't really care. Once you fix that decimal point, I'm going to shift it out of my logic as soon as I have a fixed decimal point, and that decimal point is always the same. I'm just going to, in my head, I'm going to multiply it. For example, if we're talking pennies, I'm always going to work in pennies. If we're talking money, if we're talking 2 decimal places, everything is going to go to pennies. It's going to get stored as pennies. I'm going to work on it as pennies. I can't have half of a penny. Now, in reality, I can, but can't have half a penny. Well, I'm sure you do, but you don't have you don't have anything over 4 digits, 4 decimal points. Okay, so once you fix it to 4 decimal points, I'm multiplying by 10,000, and I'm just pushing that decimal point out of it. I'm going to keep that idea of 10,000 around, and every time I show it to you, I divide by 10,000 and put it back. But I'm going to work in 10,000ths of a dollar. Those are called mils, by the way. Yeah. 50 mils is half a penny. Yeah. Its name is mil, and a mil is 0.01 cents or $0.0001 is 1 mil. But when I'm talking about real or float, I don't know where that decimal point is. Now I've got a problem. If I don't know where it is, I have to store it in a different way. I can't no longer store it as an integer. Now, if you give it to me, I can convert it to, if I know, where it is. But if you give me a number that has a pi in it, right? If it's got anything, if it has any part of a circle in it, if it has that Euler's constant in it that is an irrational number, kind of like pi, I'm going to have a number that I cannot represent as an integer. So I've got this, they just give us lots of trouble. And when I insert into them, so R is real, so I'm inserting some stuff that has lots of decimal places. These will give me lots of trouble in adding and subtracting. These will provoke what we call underflow, meaning that I'm going to have a tendency to lose this last little piece of the decimal in a repeated addition. When I try to add stuff up, I'm going to have a tendency to just drop that off the end of my transaction. Okay. And so when I want to know something, okay, so I want to find numbers that are 1. Very seldom, whenever you're doing anything that has to do with a circle, what is the circumference of a circle given that I know the radius, you can never tell me exactly what that circumference is. I know that the radius is 1. What is the circumference of the circle? 2 pi. Well, what's pi? Well, you'll never get it nailed down. So I don't know how accurate you are. So I have to say, for example, look at the ID of 1. That's pretty close to 1, isn't it? If it were $1, would you bother me about the whatever this is out here? That's not worth fooling with, but it's something that you're going to get as you are calculating things like interest compounded continuously. You're going to get those pieces of a penny that are so far out there that you can't even use them. So which ones are 1? Is that 1? Is that close enough to 1 where you're going to call it 1? Number 2 clearly is. What about this one? Is that close enough to 1? Would you call it 1, Jocelyn? Okay. If you can get that close, you give me that, if you're within that, you owe me $1,000 and you're a penny short. Oh, don't worry about it. Okay. So the question is, how can I get these? If I select where it's equal to 1, okay, select splat from real sample, where R is between 0.99 and 0.1, 1.01. This will get us all 3 of them. My preference, select from real sample where R is greater than or equal to 0.99. Okay. How I might do it, declare. Remember that? Now I have to do this inside of a begin end block. Declare at. What does the word delta mean when we're talking in mathematics? Okay, it could mean increment. Delta. You use the Greek letter delta, meaning a change, an interval, a range. So this is going to be what I consider reasonable. Okay, as numeric. Let's see. What is he? 9 digits. All 9 of them are to the left of the decimal point, to the right of the decimal point. And my problem is I'm always forgetting to put that silly at sign. I'm always typing delta because I program in C and I program in the programming language from Oracle, which is like Pascal. Well, we don't use that. This language is the only one that uses those at signs. Set at delta. How close do I have to be before you're going to let me call it? There. How close? It is always good practice when you have a 0 point to put that leading 0, even if the system doesn't make you, if I'm talking about a number less than 1, it is always a good practice to say 0.00000. How about that? If I'm that close, will you let me call it the number? Okay. So the delta is my level that I'm willing to accept. Select. See if I can get this right. Like that, where R is greater than 1. Let's see, greater than 1 minus, and R is less than 1 plus. 1 plus delta. I will usually space when I'm going to go into, so notice that I have a program written here. This is this is what we call an anonymous program. And I could write this into a function. I could give it a name. So I could, create a function and give it the name, and then I'd be able to call it and pass it an argument. I'm not quite ready to go there, but for right now, this is just when I have begin end block. I am grouping stuff together into a program. So this is our first SQL program. I usually put a semicolon at the end of the end statement. It is optional. Question? Nine digits, and all 9 of them are to the right of the decimal place. To 1, 2, 3, 4, 5. I don't think I have to count this one. I think I can have 9 digits to the left of the decimal, to the right of the decimal place. So when I execute this, I don't know why I'm losing the. Something interesting has happened there. Look at that output. What happened with the ID number 1? It's telling me that value of R is 1, but it should be 1 with 13 zeros and then 1, 1. Probably what happened was when I said I plus and minus, probably it probably changed something over here. I'm probably truncating. 1, 2, 3, 4, 5, 6, 7. No, I can't explain why it truncated the ID1, the value, the R value for ID1, but it did not truncate the R value for ID3, or it didn't promote it. I would have to go in and do some experimenting with it. But anyway, I know that that those records are the ones I want. I didn't change that value of R. It did not change R. It just showed it to me differently, and I'm a little curious why and what it's doing there, because that's something that that piques my interest right there. That is the way I would do it, though. So I would have delta as a constant, and when I ran the code, delta would be 0, 0, so 1/100,000th. If you're within 100,000th, tenths, 100,000ths, 10,000, 100,000ths, if you're within 100,000th, I'm going to call it close enough. Is greater than 1 minus delta, greater than or equal to 1 minus delta, less than or equal to 1 plus delta. Okay. This is typically the way in programming that you have to check real numbers. You have to say, well, how close do I have to be before I'm going to call it that? And then you have to ask, are you inside of that range? And this just goes over and over again. You'll see this so many times because there's just so many things that I can never give you an exact answer for. I can never give you an exact answer if I have anything that's ever got a pi in it, if it's ever got that Euler's constant E in it, if it's used as anytime I have a natural log in it, and if you start computing interest rates, the value of an annuity or anything like that, you're going to have an irrational number. So if you're going to say I'm okay if I'm within a penny, then you have to check in that range. So is it greater than plus 0.1, less than 0.1? So am I within a penny? If I'm within a penny, I'm going to say you have $100. $100. It's $100 if it's $99.99 or more, or if it's $100.01 or less. I'm going to call it $100. Something like that. This is commonly done. I'm getting out of our this is in the slides, it's searching for rounded values. I'll let you look at that. Dates and times. You can take a look at these. The dates and times are get date, get, what is get UT date? The second one, get UT date. What is UT? What? The University of Texas, of course. If you talk about UT, what is universal time? Uniform time. What is the right word for that? UT? It's not UT. It's universal time. Anyway, it's the time at the prime meridian in Greenwich, England. Is that right? Okay. I believe it. I believe that's UTC. What day is it at the observatory in Greenwich, England? I don't know why they use that one. System date time. Sys date time. You will find that there's another one called sys date, and you can use sys date time. It makes a very nice number generator for primary keys because it gives you the date and the time as a timestamp. And if your data aren't coming in just really, really right together, now if you're working for Amazon, then you probably couldn't use that. But if you can, if I know that I'm working in a doctor's office or something, and I take an appointment and then I take another appointment and another appointment, I can use that timestamp very nicely as a primary key. System UT date time, system date time offset. I'm going to let you read that. If I give you a date, the day function returns a string giving me the day of the week, I think. Month and year. It might be a number. I'm going to have to look that one up. It's probably in the textbook. What does day give me? So if I call day and I give it a date, what does it give me? Let me see if I can put that together and try some. I'm going to try it. Select sysdate time. And you have to have the empty set of parentheses on it. So let's see what this gives us. Gives me the today's date and the time. Now I'm going to feed that to the day function. Now we know that today is Friday, and that might give me an integer, or it might give me FRI, or it might give me Friday. I don't know. So I'm going to test it and find out what it gives me. And it gives me 3. 3. Why would it give me 3? Monday. Why 3? Huh. But, oh, okay. Yeah. Yeah, okay. I was expecting it to give me the day of the week, but it's giving me, okay, so it just gives me just the day. And so then if I were to ask, what month is it? Thank you, Jocelyn. I'm expecting to see 11. And I do see 11, okay. And I expect year to be 2017. Back to the slides. I'm sure there is a way to get day of the week. Adding dates. Date part number date. I'm going to let you read about that. Date offset. This EO month is one of them that is going to appear in the exercises. EO month says that's the end of month. The date that the end of the month will be. I think that's the only one that we're going to use of that. And when you do the exercises, this will be important. Please listen up right now. Before you do the exercises, please refresh your AP database. Okay. Because it asks you to find all of the invoices that are due less than 30 days from today. Well, today keeps advancing. Therefore, they go off into the history. And my problem I had with that database is that it was written in 2012 or 2011, and all of the invoices were 15 or 20 years, well, not 15 or 20, 2012, 5 years old. Well, gee, when you came to this part of the question, it wouldn't. So I rewrote the SQL such that every time you refresh the database, in other words, you just run that create ap.sql script, all of your dates will be brought up to current dates. And if you have changed any of the data in there, which you may do as you please, it will wipe that out and put the data back fresh. Okay. The other thing I would ask you to do is, when you do the data, please have your database that we are using in the class, the database name in the class. What is our database name? AP_DB. So at the beginning of all your scripts, and for the people listening from the internet land, at the beginning of all of your scripts, I expect to see use AP_DB. Now, if you want to use a different one at home, that's fine. Use a different one at home. But when you turn in the program, I want the first line of it to say use AP_DB. This is so when I'm grading it, I'm on the train and I'm bouncing around and I'm grading your code. I like to go there and I download your script into my SQL server, mine, on my computer. And then I say execute. And then I look at how many rows did I get back from that. So it just executes the whole thing. And I'm expecting to see 327 rows come back. If I come back, if I look at down there and I say I got 327 rows, I'm not going to look much further at your code. I'm just going to glance through it to make sure you didn't just do something to return 327 rows. But you didn't know how many rows you were going to return. So I'm going to write a solution. I'm going to see how many rows I got, and then I'm going to see if you get that. If you don't, then I'm going to go through and step through it and try to find out which one is different. And then I look at that code. Let's see. But if you have a different database in there, and I don't have that database, as soon as I try to run it, I get an error, and that's that. It is possible to get a different number of rows than I did and still have a correct query. Yeah, that happens. And then with that, I just have to go look at it. And then I remember that. Oh, yeah, that number's right also. Are there questions? So also one other point I want to make, and I'm going to start taking off if you don't do it. When you do a table join, I do not ever want to see the word join without, unless it's preceded by the word inner or outer. Okay. And don't drop the word as even when you can. Later on, you do as you please. And here, I want to see inner join or outer join, left outer join or right outer join, not just right join, please. Questions? Okay, let me just see if I've missed anything. I'm going to let you read it. A lot of this stuff is fairly tedious and not particularly subtraction, good grief. Okay. I want to mention briefly here slide 31. Let's take a look at it. I'm going to have you seen the case logic, also known in C as switch logic? Have you ever seen this before? Case terms ID. When terms ID is 1, then you will select net due in 10 days. Else, when terms ID is 2, net due in 20 days, 30 days, 60, and 90. On 31, I'm not going to cover this in detail because this isn't really SQL. We are stepping now into the programming language. I would not do this in SQL. I would do this in T-SQL because I have a select statement over there just like this. But it's kind of migrated into SQL, at least as far as SQL Server goes. Does this make any sense to you? In other words, when it's one, a couple of things that I'm a little unclear on. What does it do when it's none of the above? Okay. I don't know. This is not pure SQL. And I don't know whether it has a default, it might be when other. That's commonly found in this language. So over in TSQL, when you do a case or a case statement in TSQL, whereas when other. So it might have migrated into here. I don't know. There is some is it always equal to? Is there a way to say when it's between 1 and 2? So it's a little unclear to me of what value this is. So I'm not going to spend a lot of time on it. Okay. I'm just going to mention as we go along. I'm not going to cover the case statement on the test. Okay, yes, they do have a range that you can put up there. When date diff. Okay, so apparently it is a little bit. You can experiment a little bit with that. I'm not going to put it on the test. What I am going to do today, I'm going to go ahead and assign the practice test due next week. And I think what I'm going to do with it, I'm going to write the test and open the test after class next week. Okay. And so we'll have a fairly short lecture, and then we'll move directly to the test will be available. You do not have to come to class to take the test. Okay? You may take it online. The practice test will have a point value of something. I think I give like 5 points for it. Basically, I just want you to do it. And people who do it will do better on the test. Plus, you'll get 5 points just for doing it. Questions? And you'll see what I'm going to ask. So probably what I will do, I'll discuss the test, the format of the test, next class period, and then it will become available. Excuse me. It will become available. Questions? Okay. Let me get on here. I'll see if Heather's still with us. Hello, Heather. Are you still there? And Valerie, I see you. Any questions? Yes, we will have an assignment, but the assignment, I will probably make the assignment for module 11. I'll probably put a due date of Friday on it. But remember, my assignment due dates are soft. For the practice test, the due date will be firm. So I'm going to assign the assignment in this one is not very difficult. And then I'm going to assign the practice test with a firm due date of next Friday. And the exercises, if you're not ready to turn them in by Friday, that's fine. Don't. Okay. But the practice test will have a cutoff on it. I don't do cutoffs on anything else. Okay, I'm about to stop the recording. This is November 3rd, 2011, and this has been the regular class meeting of ITSE 2309. I'm going to end the recording. I will be available to take messages on Canvas. So if you have any questions, people who are listening, if you have any questions, you can go on to Canvas and I'll be happy to take pretty much a chat there. I'm gonna go ahead and end the meeting because the system has to do about an hour's worth of work to it, or about 20 minutes worth of work before I can upload it. So I'm gonna end the meeting to go ahead and get it uploaded, but I will have my Canvas messages open at this time. Bye-bye.